So, the training process for reinforcement learning, or RL, can be painfully slow. And this isn't always because the algorithm is bad. It's often because data collection is bottlenecked by the simulator. Our wrapper attempts to help solve this by parallelizing experience collection. We run multiple environments in Unreal at the same time. This allows us to gather more rollouts per step and train faster. We also provide modular building blocks so that developers can plug this into the RL library of their choice. Next, and for the rest of this video, I'll be walking through our pipeline and framework and how it makes this approach clean, scalable, and easy to use. So here is just a general process overview. At a high level, the training process will be utilizing two classes to communicate with Unreal Engine 5 and to kind of complete the training process here. Admin thread talks with UE5 to discover the environment, get the metadata and config and stuff like that. That'll be needed later on to set up the training. And then it'll pass these information into InthThread, which uses the information from admin thread to spin out gym environments. The gym wrapper then handles the data side of the communication with Unreal 5 and an RL library of your choice. So that is done using the INFs originally created by InthThread. So with the above information we have already went through, we can easily create a simple and minimal training script. This is essentially the smallest end-to-end script here. We will first start admin, wait for handshake, then build gym environments with InthThread. So after that, we have the gym environments. We will need to vectorize them for SV3. This is the RL library of choice for this video, but other libraries will be compatible as well, just using the same process. So as seen in this slide, if isMulti is true, we launch a subproc vecInv to parallelize the sub environments. Otherwise, we will just use a dummy vecInv for a single instance. With the vectorized environments, now you can pick an algorithm to train. And obviously that would be by your choice. You would pick based on what you're doing. And after training is done, you would call close, which will cleanly terminate the inf threads and also the admin thread, relating each section back to the flowchart from the beginning in the next few slides to give you guys just a bit more detailed view of how everything functions. First up is going to be the admin thread part. This admin thread sets up the section that handles the initial interaction with Unreal Engine 5. It'll get the metadata needed to create the gym in later on. As you can see here, it'll get the metadata, push it into a dictionary, and then if you see the kind of dashed arrow there, it'll be passed into our inf thread, as you can see here. And so up here is the gym environment part of the training script. The inf thread takes in that metadata from before, and then creates one or multiple gym environments. And how gym environments will be used, which is represented by gym wrappers here, is related to essentially the UE side of this. So once training is started, gym wrappers of each sub environment will pass training data between the RL library and also the UE5 sockets to train the figure. As you can see here, just to recall, the UE5 sockets are spun out by that for loop here. So yeah, after your training is done, you will be closing out everything. This would be the last part of that end-to-end kind of small training script we had earlier. And what happens here is by calling close, you would just cut off the connection between our Python end and also the Unreal 5 end here. So finally, zooming out, kind of like this is how everything essentially fits together. Up next will be a demo of the training process. And if you want to take a closer look on how the training script is used in the demo work, it is also on our GitHub page.
Let's go through a quick demo of our simulation actually running. You can run this yourself by checking the examples folder. If you remember from the initial overview video, our objective here is for our character to reach the box on the platform. We went over the Python side earlier. Really quickly, let's take a quick look at what's happening on the Unreal side. First, you'll see that we have a new multi-environment bridge object. Taking a look at our implementation example, there are a few changes from the single environment, but the overall flow of implementation is the same. We still have 5 functions to implement. However, we now have X number of controlled pawns that the bridge needs to handle, so we need to store each pawn's information. So now we have arrays holding references to the controlled pawn and the associated values for each pawn. So implementing each function, we now need to use a given environment ID to retrieve the reference to the controlled pawn and its values from an array of references before we can proceed with implementing the rest of our loop logic. Everything else should be pretty much the same as the single environment. So moving on to the level blueprint, we'll see that our initialization logic has changed. Remember, instead of setting up for a single pawn moving around the level, we need to track X number of pawns. So in this example, we're going to run 15 parallel simulations. So we're going to set up size 15 arrays for each environment and the values we need to track. Great, we run our init function with 15 environments. And in this loop, we're actually creating the pawns, our little humanoid, we're creating 15 of them and adding them to the array of pawn references. Now that our Unreal environment is set up, connect is going to be called, we're going to spawn the admin thread we mentioned, it's going to pull for a connection from the Python side, and when a TCP connection is successfully established, we send our TCP handshake containing all the training details for a simulation. This will finish setting up the reinforcement learning loop on the Python side, spinning up the parallelized environment processes as we talked about before, and on the Unreal side, we'll receive and store the socket for each environment process, which is going to be 15 in total. With that, our bridge will handle piping all the data from our pawns to each separate environment. Now let's run it. We'll start our Unreal environment, and as we mentioned before, we'll have an admin thread containing a socket waiting to accept the connection from our Python program. So we'll run our Python script, and as you can see, we've connected. We can see our little bot begin learning, except this time we have 15 instances of him instead of 1, all performing actions and gathering data at the same time. So to summarize, we've gone over how to set up a Python training script and run multiple environments in parallel. If you have any questions, feel free to send a message or leave a comment.